And more recently, early on, we ran some meetups. I'll get to that in a sec. And more recently, a conference that we run here. And we'll dig around there a little bit more. But also, we help out with some of the course materials. So, making sure that Swinburne is on the mark with its topics in future years. And I really enjoy that bit, it's good. And I'll also do a little bit of mentoring with various students and PhDs and things like that around topics, industry, and little bits and pieces with Swinburne. But who am I? I'm a software engineer. I studied at Monash University in Clayton about 15 years ago or so. And right now I'm what's called a digital specialist at Toyota. And I'm there really helping out with what I'm talking about today, actually, which is like CI, CD concepts. So why would I think that that's quite important? I think I studied a lot of the programming topics at Monash. They did a great job getting me prepped up for all the programming skills. But when I landed in the industry, I learned a lot about probably two things. Really agile topics became really prevalent about 12 years ago. I started to show up, and as a part of that was continuous integration. And I think when I was studying, I knew very little about that, but I met a whole bunch of people from HP at the time that were doing printer drivers and things like that. They were popular things to build for HP, and learned a huge amount about CI, and then a lot of businesses really wanted me to kind of do that for them over the years. So same thing that we were building at HP, or with the HP engineers that started doing all that stuff. So, but my specialty is probably light and software testing as a whole, but I'm a software engineer. So some people might call it like a software engineer in test. I'm really a software engineer. I do. Oh, no, I don't.
Oh, yeah, no, speaking one. You too.
Okay. So if you got your phone there, you can just chuck this in. MST got QA. This was something I started about 10 years ago with one of my mates. It turned into something much bigger than we realised at the time. But it was about 8 people drinking coffee, talking about software engineering and software testing and things like that. Eventually it turned into 3,500 members. Which is like, what? How is that possible? I don't know how that happened. But we run topics that help people really get up to speed with core software engineering and test-driven development, software engineering test topics. We saw it as a trend that was happening. A lot of software engineers would class themselves not very good at software testing, but actually most of their jobs require them to do it to succeed. So we started doing topics on this stuff. It was really, really popular. We've got 2 talks coming up at UniSuper. We're flying in some people from the US. They're on a website that's called Cypress.io. They build software testing tools. We're doing workshops for them. They're coming out here, and we're doing training courses with them. But then the big one, which is at Swinburne, which is TCompo, which is pretty cool. This is the one that we run. We have speakers that come out, talk for the day, drink coffee, meet some people from industry. These, interestingly, on that resolution, I'm having some problems. Sarah's from Microsoft, so we've got Microsoft coming out this year, which is pretty cool. Really excited about her topic on security. A number of people, Intellimatics, ThoughtWorks, Redify, a cloud guru of people that do cloud training topics. This guy, Lars, he does videos all day long on how to use Azure, or Azure, I think as a lot of people call it. He's an amazing trainer. So we've got some really cool stuff coming up. But enough about that. What else do I like doing? I like 4-wheel drives. Getting them covered in snow. I've got children, a couple of kids. Yeah, so pretty busy. Those are my 3 things. I'll probably do with my life: Toyota, TConf, and my children. So. No. So, let's get in there. So, why would businesses really think that continuous integration or continuous delivery is like a fairly significant advantage for them? They see it as just an outright competitive advantage, how to know that something's operational and then make those changes quite frequently to the website. So be able to make frequent changes, often in a safe manner that's cost effective, that doesn't have to have lots and lots of staff to see that actually happen. In the old days, you used to have testing of 200, and they tell you that something's good in about 3 months later. Technology companies want to know today and want to go out this afternoon. So be able to react quickly with fixes, hot patches. You'll notice like Microsoft hot patches all the time. All the websites that you know of, see carsales.com.au, all of these are patching every day, maybe 4 times a day, maybe 400 times a day. It just depends on how far along they are. I think Carsales was doing, I worked at Carsales for 10 years, I think Carsales was doing at least, it must be 20 hot fixes a day, possibly, in varying bits of the system all throughout the day, and that includes new features. So what we'll cover today is really Agile, some of DevOps. I won't go really deeply there. We'll go deeply into CI and a little bit of CD, and then some of the things about how industry do their releases, or what they expect of you when you go out and get a job coding, programming, BA, project managers, what they kind of are thinking, just generally. Might give you a bit of a leg up in an interview if you can talk about this stuff. We'll get into that a bit later. So what's the foundation of really continuous integration? You might have, say, a team of 6 developers or so in a system. I sometimes see up to 20 devs in a single system. That's quite high number in a more monolithic system. But they might be committing code or versioning that, and then that's often sent off to a build server and built and deployed into a test area or somewhere safe for testing that won't damage data and things like that. And a computer will run a bunch of tests, or multiple computers might do that, give you some results back, and then you keep feeding that cycle. Fix, update till all your tests pass, and then you might go off to production. That's kind of the first bit of CI anyway. You might ask yourself, what the hell is the difference between continuous integration, continuous delivery? We'll get to that for a sec. I really like to think of continuous integration as the bit before you go to production. And then in this case here, which they call continuous deployment, but I think a lot of, they mix and match that name a little bit. Continuous delivery is really the bit after your tests are relatively happy with it, you push it to production, and then you also test it up in production. So it's completely unmanned delivery to production without having to have a human touch a keyboard. That's really the foundation of what a lot of businesses these days are wanting, particularly if you're in the .com kind of sector. You'll see it less with big databases SAP, but they're still thinking about it, it's a more challenging problem for that sort of system. Then where does continuous delivery and DevOps kind of sit in this here? It extends that concept a bit. So we were just talking about package and plan package release. This bit in the middle here, this section here. So this is all done by code or some kind of piece of software, not much human interaction. So package, release, configure, monitor. And then, so this a little bit back before here, verify, plan, and package. We'll go into exactly what those things mean, but they're really just covering what is continuous delivery. So, we were talking about it before, so code, which was the developer there, build, which we're talking about build servers. If you say you've got a C# server, it might be an MS build server with Windows or something like that. If you've got a Linux server with Node, you might be doing some like npm install action inside of some kind of build server. And then test, you might have some kind of NUnit or something like a Node.js package that would test something like that. Package that up as an artifact. I've seen it as simple as literally just zip up artifacts. In the C# case, like zip up a DLL and just copy it to another server and unpack it, and off you go. That was in the early days. It's got better than that. Configure, often that might be something to do with AWS. It might stand up a server or CloudFormation script or something like that. Stands a server up, drops it in, starts it off, and then monitor it, and we'll get into exactly what that is, but you'll have statistics on, say, CPU usage, number of clicks, all these sorts of things. There's a whole lot of tools that will go into what that means. But really, what is DevOps? It's trying to bring, I would hope I'm sort of somewhere here, like somewhere up in there, somewhere. So, development, software testing, and operations all merging their skills together to build what is DevOps. This is a really big thing. You'll see lots and lots of jobs with the title DevOps. For right or wrong, I think some people debate whether you should be called a DevOps engineer. I'm not fussed either way. I think you really just, it's about trying to do a little bit of operations and trying to do a little bit of support and development and trying to do a little bit of software testing, and that makes a good software engineer, I think, just generally. Right now, what industry is looking for in you is someone that does those three things. Yeah, so it's good one to think about when you go into interviews. Is be open-minded to having a shot at doing some operational activities, be open-minded to doing some software testing, be open-minded to do coding development and various things in different bits and pieces, and make yourself available to do what's needed to get your software out the door. That's really what it's about. Some people like to think of their DevOps maturity. I think Atlassian does a really nice job of this, about where they want to be. They want to be level 4, of course. But not every team is right there, particularly if you're like a relatively newly established team. The first version would be, do you have version control? Which sounds crazy. Everyone laughs about that one. But there are projects that you might bump into every now and then in the industry that are not version control, which might ring some like general alarm bells for you, and you probably want to go well and start actually first things first, get some version control. It's a good one to do. And really then doing something about how do you understand what your customer wants of you, collating that up, and then having regular versions which address what your customer needs out of you. That's really like first cab off the rank kind of thing. Then really having some kind of form of automated pipeline, and you'll hear this word pipeline. It's really just continuous integration or continuous delivery, or a variation of the two. And can you get that software from the first line of code written to production safely without too many defects within about a week. And if you're doing that with a piece of software and things are going relatively well and you'll be able to consistently do that every week, you'll be DevOps level 2. Then you start optimizing. There might be a whole lot of bunch of manual stuff that you have to do in that week, and you've gradually sliced that down to a program that can do that for you, and you can release it every day. So you can go out to production every day, you feel comfortable about it, things go relatively smoothly, customers are not complaining about what's happened to the system, it works, goes out the door, job done. And then your operations team are with you in your delivery activities would be the final activity. So the team that is doing your operational activities with your customers works with the product delivery team. That's really the big one. So I think one of the trends that I've seen happening more and more and more is there used to be this 3 tiers of support. I'd say that really level 3 has become developers like yourselves, supporting their own system, owning their own outcomes, and that's one of the things that you might get asked about. Are you able to do support calls? Can you pick it up when it's really, really broken and listen to what's going on and then fix it? I'm seeing more and more and more of that coming into industry. So they call it a bit like the coal face a little bit, I guess, is that you get to kind of see exactly what's going wrong and what your customers are. Sometimes I think 20 years ago, when I was first starting out, there was quite a strong separation between what is support, who is fixing production problems, and then who's delivering future product. So they might be separated. There used to be some thoughts around that was more efficient because the product teams wouldn't get interrupted, but you might accumulate some customer complaint levels. So this push for DevOps came. I'm going to keep touching on a lot about Spotify, I think. People find this one pretty interesting. There's a bunch of, I've kept all the references there. I'd recommend going away and you can just Google this. Spotify Engineering Culture Part 1 and watch this when you're at home. I do play it. I might come back and play it. We'll have a look at the time and see how we're going and see how many questions we've got. But really, I think a lot of the core.coms in Melbourne are thinking they want to do this, or they're already doing it, this Spotify culture piece. I hear it all the time. Really, it's coming back to what we talked about in the first slide, which is being able to release often and easily without much pain or drama or lots of heavy lifting. And Spotify, I see it more now when I use the app itself, but they basically have little panels. You'll see it all the way around Spotify, and each of the panels is owned by an individual team. So one team might own Discovery Weekly, another might have the latest hot pop songs, the latest rock songs, so on and so forth, and they own that space or that feature. They're able to turn things on and off with the click of a button. Something's broken. You might see one day a panel's just missing on Spotify. It's because something's going wrong and they've just turned it off for the day while they work out what's going on. It's very, very common. You might go, where did my sign-in button go on that website? But that website's still up. They're probably having some problems, but they've kind of just turned it off for a little bit. And you're just getting general access. You're not getting the member features and things like that. You'll see that quite frequently, and they're probably having some kind of issue. The good news about this toggling thing is the whole website's not down. So back a long time ago, when everything was coupled together, the sign-in would go down, the whole website would follow. These toggles let you kind of control whether things are broken or not, which is a really nice little feature. And that sort of leads into smaller services, or what you'll hear is called microservices versus monolith. There's still lots of monoliths out there in industry, and they're all sort of thinking maybe we should make them a little bit smaller. They're at varying levels of slicing it up into little pieces. I think Cuzzells used to have 2 systems. They now have 500 small ones. So one goes down, all 499 are all right, the rest are up and running. In the old day, if one went down, the whole shebang went down with it. So dividing it up into small pieces gives you lots of ability to build resilience. You can divide it into teams. Teams can own smaller pieces. You can get down to little teams of 4 instead of having big teams of 50 or 30, and things get a bit more manageable. So microservices have all sorts of awesome features that make them a little bit easier to work with. So if you haven't seen this before, I imagine you probably have seen this, but you normally have a UI component, some little microservices that deliver JSON bodies is the typical one I see. There's a mix sometimes. Some of the older stuff is SOAP. The newer stuff is RESTful in the middle. You don't see so much SOAP development these days. And then some kind of data store. So this is a big thing that we were just talking about, but one big thing that Spotify's pushing for was really big projects equal big risk. As soon as you start trying to do an 18-month project with 200 people in it and you're going to do a release in 2 years from now, you're escalating your risk each time that you do that. Or we could do lots of little releases, so do 500 little releases. Your risk profiles gradually diminish into something very, very small. So they're really, really thinking that all the time. A lot of new modern companies are thinking this too, about small releases are low risk, big releases are big risk. So, pretty cool. I might skip over that, just see how we go for time. This might go, what the... I'll point out a few. One of my friends said the other day, did you know that there are, just in that test bit, in the bit where we're talking about continuous feedback there, in Git, in the last 3 years, there's been over 6,500 software testing tools committed to Git. So this is probably actually just very icebergy, in a sense that it's probably just really a tip of actually what's out there and what you can learn about. This is what's probably really cool about IT actually, is that there's an endless plethora of things that you can go off and learn, and I'd say I probably won't know like 7 of these really well. Maybe a few more. We're going to cover a little bit of each of these and what does it mean for all of these tools. So don't get too freaked out by that. It's funny these. So the one that I see lots and lots and lots of, and if you're sort of about to go get yourself a job, you probably can go and read all the help. One thing about Atlassian is you can go read a bunch of help documents about how this system works if you haven't used it. Does everyone use Jira? Anyone use Jira? Yeah, cool, couple of people. I think just about every company has Jira in it these days that I know of that's doing software development. It does your task management, your defect management. Those two things that we just talked about that we have to manage. So version control and then manage your defects. Jira's doing that for you. Gives you reporting and other task management. You can see this one here. So if you're less familiar with Agile, but one task is often called a story here, and it's in progress. And you can see that Friendly Robot is working on it. John Smith made it. and you can see normally it would have a better description than this, but this one says create research brief for testing the app. So it's just a dummy one. But often I see here, screenshots, mocks, snippets of like what it should do with acceptance criteria and things like that. Depends on which company. They're all a little bit different. Some companies just like to have that one-liner and you talk to each other about what you're meant to build. Other companies like to have 2, 3, 4 pages of how to build something, particularly for a vendor or a consultant or something like that. I want you to do this. You've got 2 weeks to do it, and that just depends on what you're working on. So you can really get something else out of Jira when you get it is documentation. These are really planning tools. There's something called Confluence. Confluence just allows you to build web pages that have information in them. Really, really handy. A lot of the time, if there's something really, really complex, I see mostly in here like architectural diagrams, things which are more than a page long of diagram end up in Confluence, and you can refer to your Jiras from there. So a couple of the nice things, it gives you some inbuilt planning tools and drawing of diagrams, architectural diagrams and things like that. Draw.io integrates straight into Jira, so you can get some really nice architectural diagrams and be able to share those with your team, refer to those when you're doing your planning and other little bits and pieces. This is what planning looks like these days. You don't really see 30, 40, 50 page documents in a folder, go off and read that and build it. It's really one page at a time, and you kind of eat the apple that way. So just little pieces at a time coming out of little stories, a little bit more management. Some companies go even further than just that, and you notice that Atlassian recently bought this, but Trello, just saying, we've got these 50 things to do this month, and you pick off the top of here, and inside of there might be diagrams and other text and little bits and pieces, and you're just dragging them off the done as it goes to production, and you just kind of keep going like that. That's just a little screenshot of what Trello is. I'm sure people are using Trello. Good for uni assignments. If you've got 20 things coming up to the end of the semester that you've got to do, just drag them into Trello, drag them across as you're done, get used to using those sort of tools. So the one that I always see, and there's really no other choice that I see getting used these days, is just Git. Are you guys using Git for your projects? Yeah? Yeah, I see lots of nodding. Get yourself a private Git account. They're free as well. It can start becoming your resume. You might want to build some tools and things like that. It's pretty cool to have some of your own code available for people to have a look at what you do, get to know you, get to know what you like doing. Do something fun in there. It doesn't have to be anything complicated. Yeah. Do you guys commit all your stuff up to Git?
Oh, that's just not your assignments.
Oh, yeah, right. Because other people, of course, yeah, that's true. Yeah. Oh, yeah, I can imagine. But for your own, I have some my code up in Git. People copy it down and reuse it. It's a good one to have. I see a lot more Docker coming into play. This is a lot about the packaging and deploy piece. I'm not super duper experienced here, so I'm just going to sort of brush over this one. But really, it's a lot about being able to package and containerize, say, a website. You might have 3 microservices up, all in these containers. Sorry, the containers are here. All in the containers. And this might be search, email, add, remove, update, delete, or something like that. Each of the little features that you might have across the website are all containerized into little packages that help you create microservices. The best thing is they auto-scale, they're easily managed. AWS hold them, almost you could host some of these things for free up in there once you've been able to containerize things. It's a pretty interesting thing to go have a read about. The ones that I really see jumping out are lots of Node.js. Mainly because they've been able to package them up. So they package up really nicely into Docker, very easily into Docker, and then there's thousands of libraries on the top of Node.js these days. Really, really impressive thing. It's literally just text files. Are people using Node at home or for study? A little bit, yeah. Go check it out. It's really, really pretty mind-boggling. Are you guys Java here at Swimmer? A little bit of Java. What programming languages are you guys learning? Just so I get a bit of an understanding.
Different languages in different units. So some C# tends to be one.
Yep.
But some units very much prefer Java.
Mm-hmm.
C++ as well, so.
Sure. I'd say once you get comfortable with your C-sharps of the world, the Node packages and Node itself start looking quite familiar. One of the big advantages between C# and Java is that it's just plain text for Node. You know how you're sitting there compiling, it drops out some kind of package like a WAR or a DLL or something like that. Node just runs. But it practically does everything that C# can do, which is crazy to think that that's even possible. And then because it's just little text files, so instead of it becoming something that's hundreds of megabytes, which you can imagine with a big website that could become gigabytes of stuff that you're shipping around, all of a sudden becomes megabytes of stuff. So imagine when you're trying to do your CI constant pushing problem, if you're having to push gigabytes of stuff around all the time, this becomes problematic. You've got to drop that in hundreds of servers, you've got to push gigabytes, 100 gig around every day. It starts feeling, well, C# and Java start feeling a little bit cumbersome, and then companies start looking at other alternates, which I'm seeing a lot more Node in the last year. Coming into play because it's really, really lightweight. So it's good little fun one to go have a little bit of a dig around in. But in the past, I've used things like Selenium and stuff to do some of the test bit. There's also all sorts of Node packages. One's like Cypress IO, which is the workshop we're doing. I've seen Nightmare.js, all sorts of other ones. Go have a look around. There's all sorts of stuff there. Another little Node package which is quite nice is Postman. It has a UI as well, so you produce all these little text files, and you push that off the Node, and then Node will test your microservices for you, which is pretty cool. NUnit for C#, JUnit for Java. All these things are good things to learn. This is about a year out of date, but still pretty relevant. Check that out because, as I said, a lot of companies these days expect you to be able to test your own code. So, can you prove that your system's working in your code? Can you do that? Can you do that for your next assignment? Are you writing Can you write a C# program and then write an NUnit test that proves that your assignment passes? It's a good question. That's what your employer might ask of you. Can you prove that it's working too? And then can you prove it continues to work every day while we do that? So you go and add another 100 features. Did the 99 you just do still work? That's a good question, right? That's what they expect of you. Particularly in our job. Continuous feedback. I'm not trying to sell any product here. I feel like I'm on a sales mission or something like that. So Zendesk. I see lots and lots of Zendesk out there. I remember how we were talking about what is agile. You're version controlled, and you understand what your customers say about you. Zendesk collates everything for you, so that you can see what your customers think about you. So when they email at support, you might get hundreds of these things. This sort of helps you aggregate, respond, take metrics, do all that sort of stuff. This is the bit where if you're an engineer and they're doing level 3 support with your engineering, you're probably reading this stuff. You're like, oh, what's that? Someone said that this is broken, and you go away and fix it before anyone, you get thousands of customers complaining about that one thing that we just saw. So Operate is something called New Relic. What's really good about this is it democratizes information about your servers. So you could go in here, check out what happened last night, and it gives you a historical record, and you can do a whole lot of analysis. So we got 100,000 page views. You can see what your response times were averaging around 1 to 1.5 seconds. With a couple that are going up to 3 seconds, you might want to go in and drill into what is that? What's this? These sorts of things. And work out which system was doing that. When you've got hundreds of systems, you're like, which one was actually out of the 500 is doing that? And I'll go fix it. Who's doing what? Imagine Samsung Galaxy devices are coming up the top there. You might want to go and check why those users are slow right now or something like that. You start correlating data. It's quite good like that. These are all tools that are just sort of standard trade tools, I think, in a way that I always see New Relic, I see lots of Zendesk, I see Jira. These are just things that are in practically every company these days, or some variation if they're constrained by budget. But they all basically do the same thing. What's really nice about New Relic is that it gives you some dashboarding and alerting, so you could have it email you when anything exceeds 3-second response time. So on average, I'm seeing 3-second response times above this. And you can escalate, so you can have it email. Oh my gosh, it's a 10-second response time. I'm going to SMS someone and say this thing's really on fire. Browser interactions and synthetics, so you can get it to click around for you and then tell you what happened during that time. So you might get that doing that every hour, and if that never responds in a flow or a workflow, tell me about it. This is called Splunk. There's a few others that are called Sumo Logic. I see sort of two choices here, Splunk and Sumo. But this is a log aggregator. Imagine when you're writing a C# program that you write something that outputs a text file that collects all your exceptions that are happening with that application. You might have your IIS logs and your application logs uploading to this application, Splunk, Sumo. You can actually go through and then search everything's happening. So imagine you've got 500 systems, you're like, which one right now is causing this problem? Okay, I'm going to go here, tell me top 10 exceptions in there. You start at the top and you work your way down. You're like, okay, it's this system, that system's causing that system to break. I'll go fix that. Go back and watch the exceptions. Okay, my exceptions are halved, and I keep going. Just keep chipping away at it. This is the operate bit of the infinite. I see really 3 hosting options these days: Amazon, Google, and Microsoft. So, interestingly, Azure in the last year, it's been getting all sorts of traction, I think, overall as a choice. And I was seeing heaps and heaps of AWS. AWS was absolutely first to the table, and as a result, is still number one, but Microsoft's really coming in strong, and then Google Cloud's going to come in number 3 there, I think, for hosting. But I haven't seen too many corporates using Google Cloud yet. Not in Australia, anyway. There might be more than that, but the two, I see them alternate between Amazon and Azure. So you can go and get yourself a nice, really low cost Amazon account. I have one. I think it costs me about $6 a year. You can go off and learn all sorts of things. Just be careful what buttons you click because they start costing you money. But read the pricing before I go recommend you go off and do that tonight or something like that. But learn how to host a static website, do the routes, build it up. These are all good skills that companies will want out of you, I think. And there's just endless stuff to read there, I think, like with the Azure documentation. Sometimes it blows my mind. It's like 3 pages of command lines that I have to run. It's kind of like, wow, I could spend all day just kind of getting my head around what is actually happening here. So there's a lifetime of things that you could learn out of Azure and Amazon. I find Azure is a little bit easier to use to some respect, and Amazon's a lot more feature-rich. It depends on what you're after. Typical kind of Microsoft approach. So, how do you build something? There's something, Jenkins is free, you can get that installed on your box. You can get it to build your C# project that you're working on for uni and get it to deploy up somewhere, anywhere you like. It's free, it's great. It's very nice because it keeps a historical record of all the commands that you've run. It's able to remote execute on any other machine. So if you've got a couple of machines at home, like I used to have, I don't know, probably everyone's in the cloud these days, but you could run multiple projects, multiple builds, see whether they're passing, failing. These are great things to learn, I reckon. I've spent much of my career helping people work out why their build server isn't working. like 15 years of why is it not building, why is it broken. It's a pretty good thing to learn. This is what I was learning at HP, but with the HP engineers, but the guys there, they wrote Jenkins, but it wasn't called Jenkins, but it was their own hybrid of what Jenkins does for free these days. But they were building it for a company that wanted something like a build server. Really all it was doing was remote executing MS build commands for a C# project. That's when it boiled down to it. That's really all it did. We didn't have Git back then, but you could go and pull off of some sort of version control. At the time it was SVN, and then it would pull back and run a Windows command or a Linux command or whatever server we were on, build, and then it would run a whole bunch of file copies and copy it somewhere to a host. That's really what it did. That's all that Jenkins does. It's not a lot more complicated than that, except Jenkins added scheduling, which is quite nice. So you can say this morning, or every time someone makes a change to your code repository, I want you to pick that file up, build it, deploy it, test it, do all this. So I see all sorts of options there. Jenkins, TeamCity. There's 20 options here. Every company has a different version of their build server. They all do the same thing. Basically, it just depends on what flavour your team probably desires to have. So, some companies might have a big screen like this with build stats. Pretty well, all the companies I've worked with had some kind of green light, red light thing happening, which is pretty cool. So, just a little bit of a few final thoughts about what I'd say for you guys about when you're going off for a job interview, but also what could you do with your careers once you start becoming a developer or a project manager or a BA, is don't kind of get yourself too narrow. A lot of companies are looking for what they would call an individual that is a T-shaped person. Someone that can design a requirement, someone that can write some code, someone that can do a little bit of testing, someone that can do some operations, some people that can do customer support, manage your own finances, do whatever it is. Out of all of these, do a little bit of marketing, do sales, they're looking for someone that has that long T, but they're also looking for someone that has expertise as well. So are you that really great developer? You don't have to be the gun, are you a really great dev? Are you a really great software tester? Are you a really great BA? Do you have that specialization, and do you have some generalization in your range of things? So I think, a lot of the people that I see that have really successful interviews and then really successful careers have a very broad range of skills that they bring to a company that is more than just writing code with your headphones on, heads down, do that. They bring a little bit more than that. So have a think about that when you start working on your career, and think about what can you learn tomorrow that potentially gives you some breadth. But university, a great uni like Swinburne will give you some great depth with your programming skills, but get out there and learn more than just coding. Not that that's something that you shouldn't strive to always improve, but learn a few more things. Well, yeah, there is a little bit. Agile's like a very, very popular thing. It's really, I've seen a massive shift from vast majority of companies doing some form of waterfall to really exiting that and expecting frequent releases. We'll just sum it up as that. But then really more than just that is building something your customers want out of you. That's really what it's all about. I work in the Agile team, but I wrote documentation each day. It doesn't really mean no. I think there's a slight misconception there around it being zero documentation. Remember how I was saying there's a tool there that says you can draw a diagram that gives you this, and that one-page diagram is what everyone uses to build everything off of that. It can be a bit more like that. You don't go away and write like a 100-page document and then write 100 lines of code and ship it. It's kind of seems a bit wasteful. It's a balance between doing the right amount that your team knows what they're doing and that they can operate efficiently compared to how much code you write and whether that works. You want your code to work first, but you also want your team to know what they're doing. So it's a fine balance between the two. But you remember how I was saying some teams they just like that top line and then for you to talk to each other about what to build? That's that first line in the manifesto, just saying we want you to work together. Some teams take it more and more seriously, that they want you to just only work together and don't pile over sign-off or heavy processes around approvals on what you're meant to do for your day. I think sometimes you see it go from straight left to right. That might be because there was a little bit too much process for the company to feel comfortable about us doing a good job. And people feel like they're acknowledged for being intelligent people, being able to make their own decisions, being able to work each day versus, it's flipping from side to side sometimes. Hopefully you're able to kind of find that balance between the two. I remember how I was talking about that Zendesk, that talking to your customers, understanding them, over negotiating with them over a sign-off or a contract. That's what I was trying to say. And then being able to respond to change. So imagine a customer complaint comes in that morning. Are you able to adapt that afternoon to solve that customer's complaint? That would be kind of really doing it. I'm probably most familiar with the iterative model, I think, mainly because I've done like lots of CI over the years. Relatively short feedback cycles that every single day worry or are concerned about whether the system works and does it do what our customers want out of us. Those probably those two things. That's what I'm really. This is probably more my own version of what is agile. I'm not so fussed about whether how much documentation or do you do too much or too little. It's like seems like not valuable discussions, but rather the are you able to iterate? Is it really high quality? Does it do what your customer want? Done. There we go. That's probably what I would like to think agile is. Ooh, so in a lot of the teams I've worked in, continuous integration is just mandated, where it's really just got to have it. Everyone's got to work on it. Everyone's got to contribute to it. Your build's got to be green. You have low defect rates. Unit testing, pair programming, and test-driven development are really at the core of what is continuous integration. We'll go into those in a sec. I've seen a little bit of BDD, design patterns, and code refactoring coming in as well into these teams. But what is the unit test? It's really about, if you imagine these are all classes in your C# program that you're writing for your assignment, you'd have hopefully one test for each of the classes that you have, whatever they're doing, and you can prove that each small piece of the program works. That's really a unit of work, a unit test. You're able to prove that that single piece of the program works. And then you have a build server that runs those unit tests and tell you that they're green or red. And on your local machine, you're also, when you first write your test, it goes red because you obviously haven't developed it or it's broken. You start writing the program, you run the test, you see it go green. Your program is complete, or it does what the assignment does, or whatever it is. I've seen this a little bit. I see sort of hybrids of it where if people that are really stuck will do pair programming together, particularly on a very architecturally difficult program, or something that is so urgent, it might be a really urgent hot fix, and the likelihood of making a bigger mistake is high. They might pair up and say, let's just write this together, we'll write a test, we'll write the program, and we'll send it off to production and see it work. I often see that with pair programming. Some people might have a junior developer team and a senior engineer, and they might want to pair those two guys to do some knowledge exchange. That person might be moving on to another project. The new engineer might be wanting to learn some more about the system. They might pair up for the day and actually learn about how the program works. All sorts of things. I quite like pair programming. I did lots of behavioural-driven development. Often it talks about what does your customer want from you. This one here talks about refunding an item. So it says given is a precondition. So given that this customer has previously bought a sweater, this is American, should be jumper, and I have 3 of the sweaters in stock. When I return them for a refund, I should see 4. So this is a very simplified version of it, but you can see it's a precondition, an action, and an expected outcome. So given when then, you might see this in all your Jira, all your Jiras that are coming out with. Remember how that description was empty? I often see that the description there is filled with this sort of text, and then under this might be like a nice diagram, or a screenshot, or a mock, or a wireframe, or something that helps you understand what the next feature is meant to do. So they might try and use this language inside of your Jira to help explain to you what the system what the system does. It allows them to conform to a standard language as well. So I see all sorts of code refactoring that happens from time to time. Essentially, if you've written some unit tests, often the interface will stay the same, but this code might be 200 lines long, and you think you can get it to 100 and make it a lot more maintainable. The interface, the test will stay the same. You refactor the internals of it to make it shorter, more compact, more reusable, more robust, whatever you're trying to do with it. And the test will tell you that it passes. Or the interface to it behaves exactly the way it used to behave. So code refactoring, really interesting one about how to do that really well. The one I love is Martin Fowler online. He's really, really brilliant at all of these sorts of things. Check that out. He's from ThoughtWorks as well. He's a Melbourne person. He's written all sorts of books on all sorts of topics around that. So this is sort of my own thoughts more than anything. But DevOps really lets you do Agile well, I think. It's a bit like a tool to be able to do an action really, really well. It allows you to release more frequently. It allows you to make changes often. It enables you to do deployments on a daily basis, updates, fixes, hot patches and features. They pair quite nicely with each other. It often removes those bottlenecks, remember, between releasing monthly to releasing weekly to releasing daily safely. So I see this is an interesting one to go read about, but this is a new thing in industry that I've seen starting to crop up. Someone that's got a site reliability engineer. I'm seeing this more and more and more. It's a bit of a spawn-off from DevOps itself. Seeing in a lot of the bigger companies, these engineers do a lot of analysis of the systems, determine whether they're unstable or if they are unstable. They write code that could potentially improve the stability of the system or improve the operation of the system. And a lot of these people are on call, or they might do manual repairs, but their goals are to really have self-healing, improving, self-reporting systems that are able to be more reliable. So a lot of you can imagine with Google's billions of users on that thing. It's got to be up 24/7. I can't remember the last time it was down. There are people behind there making sure this is always working. And these are new jobs that are cropping up around the place, so might give you an edge in the interview. I see productivity engineering also coming into play. Really a mix of release engineers, site reliability engineer and test engineers becoming site reliability engineers. So it's possible that my career turns more into a site reliability engineer over time. It's quite probable. These are all new jobs that are on the market. There are also jobs that are wanted, but there's not many people out there that are doing this stuff. So it's kind of like, could give you a bit of a leg up. Software engineer, computer scientists, all suited to these kind of things. This is a bit of a subset of DevOps, but blue-green deploy. So imagine you've got an unstable build. You release it to the blue servers, the blue piece here. Your live site is on the same servers, but it's running. It's got traffic running on it. You actually do all your tests on this replica that has no traffic on it. When you're confident that this is ready, you release some traffic onto this bit. You might do 1%, you might do like 5%, you might do 100%, and you see if the new version is stable, and then roll over. This becomes the new blue, which has got the latest version on it, and this becomes the green server. So the server itself is forever swapping. Back to front, on and off. And you've always got two versions available, which is really good. So imagine the scenario where you actually do flip this to green, and something horrendously goes wrong, you just go "Boop," and put it back to the last version, and everyone goes, what happened? How come you fixed it so fast? Well, you just rolled back. Bit of a magic trick. A lot of engineering managers love this one because it's like someone calls up and says, what have you done? And then, what do you mean, what have I done? And it's already flipped back by the time you've, finished the phone call. Or put the phone down, it's already fixed. A little bit of a sort of sleight of hand, I guess, approach to operations. Quite like that one, use that a lot. A more extreme version of that might be beta testing. You might allow one or two people onto those blue servers for a period of time. I see extended beta programs as well. I think Gmail was in beta for like 2-3 years. Sometimes it can just mean that the users that you're encouraging to come on, you're just giving them a little bit of a warning that site's not quite up to scratch, but you want to get some feedback. You want to do constant patches every day. You want to get to know what's going on with the system before you go and release it to all your customers. It's really what it's about. It's all about feedback. Yeah, so you might do this percent thing that we're talking about. You might do 1%, you might do 0.5%, you might do everyone to be really brave. It just depends on how you want to go about it. Let's go. I hope my phone's working. This will do. This is Google Analytics. I recently just did a few courses on this. This is a test account. It's faking traffic coming in and out of it and doing things like that. So you can see over the right here. Right now it's saying that we have 21 users on the site. What's going on? And what's really cool about this is what's your most popular page there. Funnily enough, is a homepage. You can also see a bit of a breakdown, so you might be able to put some triggers. If this action happens, I'm making money, which is kind of fun. If you've got a transactional lead type website, you might be able to put a dollar value on it. You can see over time, you can do ranges, so we'll do the next 90 days, it gets a bit more interesting. But you can kind of see, this might be a bit concerning to me, but a really heavy drop in traffic in the last period, that might be a big concern. You might have done a release here. You might have released your beta program and everyone didn't like it. These are all great numbers to kind of have access to. You can also see you might have done some marketing. And you can see that this is not a very good example, but a lot of the time you might see LinkedIn, Facebook, Google, Gmail. You can kind of see which out of your websites is behaving really well to marketing campaigns that you might have paid for or something along those lines. You can see your active users, you can see where they're coming from for what country. If you're lucky enough to have an international website, you might be getting lots of hits there. You can see a bit of a breakdown of site, store, basket, so on and so forth. This is a really powerful tool. It's very simple to set up. It's often free, depending on how much you're using it and what you're using it for. Really, really great one to learn some skills. There's all sorts of free tutorials from Google on it, all sorts of YouTube channels on how it works. There are people that just have a career in GA, learning how to use GA. It's that complex. There's all sorts of big data queries underneath it. You can learn a whole many years and years of how actually GA works in and out if you're working for a commercial website. They're often tied with jobs which are search engine optimizers, people that optimize websites and then use that data to go back and re-optimize and get traffic to come in. There are people that just do this full time. Can be quite an interesting job if you like piling over numbers and working out where problems exist. I quite like to do a bit of a number kind of guy. Worst thing is you can get it on your phone as an app, so I can look at it all the time. What's TCOM doing? Don't do that. Wake up in the middle of the night, wish that did better. This is a very straight out one. How to get a job. The simplest way is really, my dad used to say this, is apply for 70 jobs. Don't be afraid to apply. You can only, what's the worst thing that can happen? No. Okay. Do the next one. The quickest way is seek.com.au, LinkedIn, get up on there, start applying. That's really, I remember when I came out of the tech bubble, it was pretty tough. Inexperienced person, lots of other people that experienced not many jobs on the market. Very rapidly changed, luckily. But I took a contract, best thing I ever did, because I literally applied for 70 jobs, got a contract. I was like, great, cool. And they called me up, can you start tomorrow? Like, tomorrow? Okay, so, it really does happen. You just got to keep applying. And it was literally over the phone, and I went in and met them, and they said, can you start tomorrow? That kind of, thing. So, but one of the other tips could be that don't be afraid to apply for that 2-week contract. Might sound crazy, but it'll probably turn into a 2-year job. Don't be afraid to apply for everything. Get in there, have a shot. All the jobs I've had, I've always learnt something out of them. So whether it's exactly right for me or not, I've definitely always learnt something from that organisation. I was lucky enough to get involved with a lot of small companies where there's only about 5 people in there, and those companies I learnt even more in, I think, because I was kind of forced to do everything. Fix the coffee machine, patch the network, build my own computer, go down to the computer store, buy this stuff. This is 20 years ago. It wasn't commodity computing then, but those jobs I learned all my stuff from. So, don't think, I wish I got that job at Google. You're not necessarily going to get that first shot. If you do, you've done extremely well. But the get in there, have a shot. Don't be afraid. If someone says no to you, that you're not right for the job, doesn't mean you're not right for the other 99 that you just applied for. Keep going. You'll do really well. But there's this kind of hidden recruitment world. A lot of people talk about that. A lot of the great jobs, the last 2 jobs I got were just last 3 jobs I got were just word of mouth. The hidden gems, the jobs that are often tailored to you, are ones that people have recommended you to come and work for them. They're often the best ones. But they happen in social scenarios. So there's all sorts of there's a .NET meetup that you could go to probably next week. I would imagine they run all the time. Go to that. You'll probably learn a whole lot about C# that you never even thought that even existed, and you'll meet a bunch of people that are looking for people that need people to work for them. Conferences, workshops, have a side project. Always have a side project. Highly recommend it. Write a blog. Write your code into GitHub and share it. Tell people about what you're doing. Find something you're passionate about. These latter things, ask a friend. Never be afraid to sort of ask, you got any jobs on the go? Because they might go, oh, there is actually a job and you're perfect for it. But unless you ask, they will not necessarily give you that job. Or they might go talk to their boss saying that this person is really great, they're looking for a job. You just never know. So have a think about those things, because I think they didn't become really obvious to me until later in my career, where I realised that I had to go that little extra mile to find that job that I really, really like doing. It's important that you kind of think a little bit outside of just that 2-page resume or applying for that job on LinkedIn. You can go a bit further than that amount of effort to get a good career happening in IT, I think so. Yeah, so I'll just summarise it up, but really, I guess my career is really surrounded a lot around CI. It's something that I would have never thought that that's where I would end up, but it's something I really enjoy, and it's something I discovered through applying for a job and meeting that person and getting to know that person that was really passionate about this concept that the company really, really wanted, and we got into it and we solved it. It's just one of those things that happens. And then get in there, apply for jobs, study hard, enjoy your time at Swinburne. It's a great uni, so I hope everyone enjoyed it. But how am I doing for time?
Oh, you're doing pretty well. You've got 45 minutes.
Yeah, good. So I've left a very long tail for questions, if you have any. If you don't have any, we could watch a little bit of that Spotify video, or we could all go home and have some dinner. It just depends on what what you would like to do. Does anyone have any questions?
Do you know of any good testing conferences that are coming up?
Oh, I might just leave that up in the background. We actually we do donate tickets to Swinburne. Don't forget that. You can get in contact with James. We like to see students there. Don't forget you can apply to talk.
Yeah, they're always looking for talks, and it's surprising. You know, you don't have to be an expert in the area. You just have to have some sort of a slightly different view on something.
Yeah. We look very much for unique views of the world. Imagine someone that's doing a PhD that's on something that is very, very unique, a new concept that we've never ever heard of. Will favour that concept over something commonly heard of. So don't be afraid to hit that become a speaker button. We encourage first-time speakers. We actually are looking for first-time speakers, particularly if you've got something interesting to talk about. We're not too concerned about having a nerve-wracking experience to deliver it. If it's absolutely enthralling, it's absolutely what we're looking for. So, yep.
Any advice on breaking a bigger project down into, you talk about
Small chunks?
from two what were projects? Was it
I guess
500?
microservices.
Yeah.
Would you like me to sort of talk a little bit about how that happens to unravel?
Isolate different aspects and
Yeah.
have things work on an isolation.
Why don't we use? Can you see my screen? Yeah. So I'll use the Spotify example, and then I'll use the car sales example. You can imagine if a monolith or a single monolith would be one code base that would run the whole of Spotify. So you'd have a single repository, you'd have all of your code in that repository, and you would deploy that whole website. This is a website. It just happens to be wrapped up in an app. So from what I understand about this is, imagine they might have a service which is just this here. Just this play function. So it might be able to have, I guess I'm not exactly sure what's underneath this, but a music file, or I don't know what format they have, but that music file is picked up and played, and that might be just one service. That service might also allow you to jump to the next track, and it might allow you to tell you what time you're currently at in that playing of that feature, and that might be one service. It's just they might call it the play service, and then underneath that might be a service which you call and say, I would like this song, so I would like the latest top 10 pop song, can you deliver me that file? And those two things talk to each other and deliver you that music file back to you. So there might be two services, and they've broken it down that way. And you can imagine each of these little buttons, or they might have the sound and volume service. So if you send it a number, it will deliver you that back, and it can talk to the other services and say, we want that. They'll definitely have an image serving outcome, I would imagine, where if you pass this song into that image service, it will return you a picture about that song, and it would be just that. It'd probably be called the music image service or something like that, or image service or something along those lines. And they just keep dividing it down into little pieces, and there might be a team that's responsible just for delivering a good image for every single song that's on Spotify, which is millions of songs. It sounds like a simple problem, but that team has got to deliver millions and millions of images every day in a quality manner that always works, is resilient to coming up and down, and that team is likely just to be on that.
So it seems like once they get that right to a certain extent, there would be a lot of downtime for them. Would they be on other teams as well?
They might own 5 services possibly, or they might own what surrounds albums or something like that. They might be the album team, and they've got 5 of their own services. But there might be an individual that just really knows that image server really, really well, and they've got to make sure that that's up. You'd be surprised in an operation. Imagine all of a sudden Spotify signs up another 1 billion users. That image server is probably not going to work, I'm guessing. But they've got to preemptively start architecturally thinking, what do we have to do if we were to go sign up another 100,000 users to that service? Is it going to survive? Is it going to work? Is it going to stay up? I'd never underestimate how hard it is to deliver 100 billion of those images well. If you know what I mean. It's actually a really difficult problem, an incredibly difficult problem. So I'll give you an example. Castles delivers terabytes of images a day. There was a team for 4 years that was just designed to work out how to get that car to show on the internet in a high definition colour. It's a very hard problem. You notice that not many car websites are actually able to deliver images of that resolution. And then deliver millions and millions of those every night. It's a really, really difficult problem. There's actually hundreds and hundreds of servers under maintenance that are actually just doing that for you. So you sort of don't want to kind of underestimate the difficulty of a problem. It's that little bit of an iceberg effect. It's kind of like, I think I could build castles in a night. You might be able to build those 3 pages, but actually to get it kind of working for any more than 10 users is a really hard problem. And then imagine 100,000 users, and then imagine 200,000 users, and then imagine millions and millions and millions of users. Delivering that kind of website is actually a really hard problem. So there were 5 people dedicated just to a service that does image rendering for that company. So, you know, that's a really, really hard problem to deliver high definition imagery. That image server does a lot more than you would imagine just looking at it, but it's a difficult problem. There is just a team dedicated to working out how to do that really, really well. and in a great manner. So you can you can imagine that there's a couple of people just there to deliver that image, and then this search, and then there's a new team and a used team, and so they're kind of all broken up into little bits. There's a desktop team. Oops, that was the wrong button.
So the microservices, do they work like request and response, APIs like that? Or-
Yeah. Do you want me to show you one? Would you like me to show you like our microservice?
If no one else has any questions.
Yeah, let's do it. There's a. I'll just sort of.
Oh, helpful.
I'll just kind of explain what's going on here. But there was a mobile team. There's an app team. There's a Android team. There's an iOS team. So you can imagine you're all divided up into little pieces of the system that mean that basically, and that's quite a common division in a lot of teams is that mobile experience or that desktop experience or that image experience or the video experience or Spotify sound experience, image experiences within that, groups of other things. But this is my favourite one. Let's do this. Star Wars API. So this is an awesome one. This is like my favourite. I used to run training courses on APIs. What the hell's an API? Come and look at Swappy Co. Really good one to do. API is really made up of two requests: a get and a post. One retrieves information and one puts it back into the system. We're going to do a get right now. I'm going to say, who's the first person in Star Wars? Come on. Please tell me someone knows this. Yes. So, let's hope this actually works. So, Luke Skywalker. So you can imagine that a website can actually do this, right? You know, it could go out and say, call this web service and tell me who's the first person in Star Wars. So, can everyone sort of understand what's going on there? You got any questions about how that works? Yes. Exactly. That's it. So, let's go in and actually look at what's going on in the world. Sorry, I'm on my mobile, which is not ideal.
So this is a Microsoft service for this one in particular, or is it?
That's correct. This is a microservice that tells you who are the people in Star Wars. So you can imagine, like, tell me who member ID 55,001 is. Tell me who that is. John Smith, Jane Doe. Tell me a little bit about that user. You could ask that question of a member service.
I'm going to ask a silly question.
There's no silly question.
So, because you can just start at the node server and then you can just have the one route, right?
That's right.
Is that a microservice?
Yes.
Oh, wow. I thought it was some, I've been wanting to find out about it.
There's no, it's not a lot more complicated than that. You might put a data service behind that, you might put a SQL data service behind that that has one user in it, and that responds with a JSON payload as a RESTful API that says 200 OK that Skywalker is one of your first users in that's a microservice. So it would be its own piece of code, and then you'd have the HTML, CSS, JavaScript separate to that.
Yeah.
You've just created a microservice.
And then you would just run that server on AWS somewhere, and it would just be running all the time.
That's right.
You could just call it.
Yeah. And then that would call that, and that's microservice.
Okay.
Cool.
Thanks for that.
That's all right.
It saved me like an hour of username tutorials.
Yeah, no, it's really cool. Probably my favourite topic, or one of my favourite topics. So this is not quite what I wanted.
Do microservices ever cause unintentional latency hits?
Yeah, of course. Yeah, absolutely. Who was that yourself? Okay.
Is that a big issue?
Well, imagine let's do the Spotify scenario. I reckon their first day that they released their Spotify services or their Spotify service, I bet they only ever planned for about 10,000 people to log on, right? My guess is that they never had enough infrastructure to actually handle what they do today. If you went and doubled your user base, that service will probably behave slowly if it was running at 100%. So imagine we're going to drop in that API, we're monitoring it, but we see that our current services are running at 100%. This is where Docker, AWS come in because they might auto-scale for you. So it says it's running out of memory, but I've seen sometimes that no matter how much hardware you throw at a service, it doesn't necessarily mean it's going to go any faster. There might be some outright bottleneck, it might be trying to do too much. Performance is a huge thing for most websites.
I guess I'm not sure whether I explained, well, I definitely didn't explain that correctly, but I'm not sure whether you interpreted it correctly anyway. I'm just wondering whether microservices have bigger latency issues than
Doing it locally. If that was like a 10 meg file where you were having to shift a lot of bytes, yes, absolutely. You always need to be careful that the amount of bytes that you're shifting out of a microservice is relatively low. I think in that circumstance, you shouldn't, with modern networks, you shouldn't see any really big latency increase. Unless you're like hosting it over in the US and then one's in Australia, you're going to get a network latency between those two endpoints, of course. But that's still only 200 milliseconds between the US and Australia. So the benefits far outweigh the losses, I think. So this is a bit better. Let's just boil it down to internet now. So when you call a microservice, it's going to not have that nice UI wrapped around it. It's just going to be this text. So it's going to deliver this really tiny text payload. You can see that the response is just that string. Very simple thing for a computer to deliver. In the headers, what is it doing? Doing a famous 200 OK. Remember how I said it's really just two commands. Get, post. This one's doing a get, and it just says, give me the first person in the format of JSON as a 200 OK, and it's delivering it from that magic server. It's you're allowed to do a few things. Get, give me the options of this, or I'm not sure what head does actually. I'm going to have to go read it. Just the header, is it? I learned something today. What is the content type? The content type is application JSON. It gives you a date, time. Cloudflare is just a cache in between. It sits in between the web server, Cloudflare, and you calling it. So you come in, you're just getting a static version of it. You can imagine a million people have probably asked, who's the first person in Star Wars API, learning how to develop APIs. Cloudflare's, you're not actually ever hitting the web server. You're just hitting Cloudflare. So it's just a cache in between. Its response was 200. It's zipped. It's compressed before it's delivered to you, and then deflated. It's in the US language. That's it. That's microservice. So it's really not a lot more complex than just a single get. And you can imagine when you're talking to any website, it's giving you lots and lots and lots of stuff back. So you might go off and call 30, 40, 50, 60 microservices to assemble a page for you. But all this happens asynchronously, so it just feels like it's just, there's a website, but it's probably actually doing 50, 60 things.
Microservices can call other microservices.
They can, yes. There's nothing stopping you from doing that. I'd say architecturally, a lot of people would say don't chain your events together.
So I'm thinking of those sorts of booking sites where they aggregate search results.
Oh yes, that probably is, yeah.
Are they using microservices now?
I'm not sure. I don't know those websites specifically, but it's highly likely with what they're doing. I see some of them use to just pop the browsers, which is what's called an iframe, which is not that. But a lot of them, if they've paid for access to the back ends of, say, Booking.com and Expedia and others that are aggregating all these websites, they're probably calling underneath, not calling in front. And just saying, give me all the things that match this date for this area, for this price, for this number of bedrooms, for this, it's just calling the back end of that. And then might have authorized, they're probably paid for access to that microservice, and they're talking to it and then presenting it. Or they've partnered with them and they're allowed to show that data on their website or something like that. So it obviously makes it a lot quicker to be able to talk between services. So if you're in a Windows server, you can talk to a microservice. If you're in a Linux server, you can talk to a microservice. If you're on a Mac server, you can talk to any server, and it's just a layer, a HTTP layer that allows you to talk to a data layer underneath that allows you to be able to do all sorts of things. Good questions, I'm like, ooh.
I have a question.
Cool.
So with decomposing larger applications into microservices, is one of the metrics that you use to stop scaling down too small, how entangled the microservices would have to be? So if you have the one unit and to separate it, you could only separate it via two microservices talking. Would you just leave it as the one service, or?
I'm just trying to find a reference to something.
Do you want to tell us what your application is? Is it a website? What's your one?
Oh, I was just thinking,
I haven't got one. I was hoping we'd get some projects rising to the surface.
I'm just trying to find this reference. I'm just going to say what it is, because I can't remember the name of it. So, often the recommendation is, say you've got a team of 20, you might logically divide your system into 3 services. Something that's relatively manageable for your team size. Something that makes sense so you're not treading on each other's toes. You might go as far as dividing that down into 20 services for 20 people, and each person owns one piece themselves, so you don't tread on each other's toes when you're making changes. It might be, you might just have a rule like that. You might just put a box around something that just says, I'm going to have 20 services because I've got 20 people. It's probably the most logical way of dividing and conquering.
Finding the places so you can do the unit testing with confidence.
That's right. So you'd often, they call it a contract. This service may never break that contract, but it always is changing underneath it, even though the interface to it just remains the same. I think there's something called solid principles. So this is a good one to go read about. But solid principles really says single responsibility. So imagine that this is a design pattern. Solid says that service should have one responsibility and one only responsibility. that might help you with your division. So if you go look at this thing and it's like, okay, it's trying to do 10 things, it's probably monolithic, or it's heading for that. I'm going to divide that into 2 key buckets of responsibility, groups of responsibility, because it makes logical sense that I should do that. Open close just says it's the interface concept. So really, open closed is about the interface will remain the same, but it's open to change underneath. So it's closed to closed to the change on the top, but it's able to openly be extended to do more things underneath of that. From what I remember, I'm a little bit rusty on solid.
So it's a bit like object-oriented design, but
It is.
from a service viewpoint rather than a data and entity viewpoint.
Microservices came from the construction of Unix, from what I understand,
Right.
and
That's what you can see.
so, which is crazy to think
But it
that
does have that philosophy of lots of little tiny programs strung together.
which are very independent and have their own responsibilities, and you pull in what you need to do the job. So microservices were designed, well, the web was really designed on the back of why Unix, or these days Linux, is so successful, is because it has always these tiny responsibilities, tiny pieces of code, which are individual tasks. And you'll notice that it's not like, you never see something in Linux that has really more than one responsibility as well. It always is DOS to Unix or grep. You don't see it doing grep and build or something like that, do you know what I mean? Like, you don't grep something and then build your C# thing.
It's like the output of something else.
Yeah, that's right. So single responsibility and you send it across. So it's kind of, microservices is just an adaptation of all the principles that were built inside of Unix many years ago. So it's just trying to relive that with a new name, I guess. Good questions. We somehow rabbit holed down into all sorts of things.
Can you pretty much like, if your program is like,
Yeah.
can you like refactor that to make it
Yes.
microservices?
Of course. So, I guess that scenario we were talking about with Castles, it was really made up of 2 systems. It was made up of a dealer backend and a retail front end, and it was 2 monoliths when I first started with them. And we embarked on a mission which was, how do we divide this thing down into workable pieces? So you can imagine when I first started there was about 15 engineers. We divided into two logical 7-person teams, 1 dealer, 1 retail. That was it. That was the website. It floated on the stock exchange, and it went from us 15 to us hiring like 400 people. So you can imagine at that point you start out. I remember one day when we climbed into the office, and it was like there were 80 people on 2 systems, and it was just havoc. And we went off at a big engineering meeting and said, we can't keep doing the way we're doing this. We have to divide it off into pieces. And the first division. Let me turn on mobile view. The first real division of activity was this tab here. So there was a team here for 7 years, a team of 7, just building all the features that sit under Sell Your Private Car. That was just 7 people. Their sole responsibility was to work out how to build a service that could sell a car privately. That was their whole responsibility. That ended up being about 20 services underneath that for about 7 engineers. So they all had a couple of services each, and you're just going off away inside of there, digging away. And then there was a new team, and then there was a used team. There's a Carfax team. There's a car inspection team, a car warranty team. Just kept dividing into different activities, and you were responsible for all the features that sit up underneath that website. So separate, it just kept getting divided down into little pieces, and the back-end dealer team, which was originally 7 engineers, became 30, and they were all divided up into separate activities, used vehicles, vehicle feeds, vehicle reports, inventory, leads, and they all just created their own services. So it was all divided down, eventually divided down. All that monolithic system eventually got turned off, replaced with new modern systems, and it just like a rolling thing. But the CEO used to say there's no system at this company that will ever be older than 7 years. So if it's that old, it'll get turned off, it'll get replaced with a new modern variation of it. So everything was forever being rebuilt, re-engineered for what the next 7 years looks like, because you end up with twice as much traffic or 3 times as much traffic, or having the support. Who would have thought we have to support phones and probably VR next or something like that? Who knows like what these guys will have to get involved in next? But it just keeps getting divided down into little smaller pieces until it becomes manageable. Does that make sense? Cool. I think we'll finish up there. I hope it was really useful, and I really enjoyed it. I'll be back next year, hopefully. And check out that Spotify and Culture. It's a really good one.
What's up,